All right, welcome back after lunch. And next I want to talk about OE-Selftest and how you can use it in your projects. So my name is Jan-Simon Moeller. I'm the AGL release manager, and I'm also on the Yocto advisory board for AGL. Yeah. Okay, so the topics in the next couple of minutes is OE-Selftest, and especially in continuation of my previous talk, the reproducible build test, and in the end I'll show you how you can add your own tests to OE-Selftest. So OE-Selftest is essentially a test framework for testing the actual Yocto build system. That's the roots of it. That's what it is. It was developed for. It's based on Python testing framework, so it integrates nicely with the rest of the bit-bake infrastructure. Why is it interesting in the context of reproducible builds? Well, to support reproducible builds within Yocto, there is now a reproducible build test. This does cover the build aspects, and OE-Selftest does less cover the runtime testing on the target, so that's out of scope. For that, there are other parts in the Yocto universe. One is p-test and the test image features, or systems like Lava that will allow you to do runtime testing. So the roots of OE-Selftest are within the Yocto project, and it's heavily used as part of the Yocto project Auto Builder. The Yocto project Auto Builder is essentially the project's test infrastructure, and it is used to make sure that every change that makes it into, well, the tooling around Yocto, but also into the recipes that make up the Yocto system, the Yocto project do pass these self-tests. Essentially, everything that makes it into Yocto has to pass this barrier. One of these is the OE-Selftest as well. So for example, if a change happens to the tooling and that affects reproducibility or that affects the build process, then this will be found within the Auto Builder as part of this. OE-Selftest is quite a large set of tests, and it takes a considerable amount of time. So on really good hardware, it takes hours. That's because we actually do run multiple builds. We actually do run, verify those actions. So it's rather heavy. Now, in context of local testing, there are parts that do make sense to replicate. I mean, for our own purposes, it doesn't make sense to replicate everything, right? That's what the project does, and that's why we use Yocto. But if we extend these tests, we can enhance our own projects and our own images as well. So reuse and tools make tools. Essentially, we try to reuse what we have. So let's take a look at the reproducible build self-test. In principle, you would set up your project in the same way as you do for a local build. So you call either AGL setup, in a case of AGL, or you call OE-init build-env if it's a plain Yocto project. And then in Pokey, there is script OE-Selftest. Either if you call it without any variable, it will run through everything, right? It will run for hours, or you specify what test to run, and this is the test, and you can then specify what test set and what test case runs. There's also an OE-Selftest -L, which gives you the long list of existing tests. Now, this is still tailored towards open embedded core, right? So it will essentially test core image minimal, and I think it's like core image minimal, core image, good question. I think Western and world. World is a special world. World is a special word because it means all existing packages. Yeah, so that's like a wild card. That is still hard-coded. Yeah, so to make it reusable, there are patches underway, and I listed that in here, which make that reproducible. Oops, that's not what I meant. Which make it then reproducible, which make it reusable, sorry, which make it then reusable outside of OE core. Where's the full screen? F11. How do I get back to full screen now? Interesting. There we go. Okay. What happens in here? So to test for reproducibility, actually we need to build at least twice, right? We need to run one build of a given image or whatever target, store that, and we need to rerun it. Yeah, so this is a quite expensive operation, but there is no way around it. So we run actually two builds. Yeah, build A, build B. And then we will compare and find out if there are differences between those builds. Let me, oops, jump on this one. Yep. Oops. Okay, internets. Now, if we are lucky, there are no differences. If we are not lucky, well, then there are differences between those two runs. And those are the ones we want to find and eliminate. Yeah? I mentioned in the morning talk that what are those differences? Yeah? So those differences can be build IDs, folder names in the binary, folder names in the debugging symbols, some hashes, and this process will find these. So how can we make use of this? So right now in the code base, without these patches that are in flight, we basically would have to create our own self-test. OE core, so the self-tests are then always hosted in a folder in lib OE-QA self-test cases. That's where the self-tests are expected. Well, I went ahead and essentially copied the reproducible self-test, removed everything that is not needed, and created my own version. So it's kind of copy and modify right now, or subclass and modify. In this case, it was easier to create a copy and modify it. So what I did is I changed the images. I changed the I minimized the package managers in use. AGL is RPM based, so we only need to check that. So the drawback is that we have to maintain our own copy, but with the patches that are in flight, this will be way easier. So in the end, this should look like this, right? So you add like two variables to your build and call the self-test. Done. Yeah, so this makes it rather easy with those two options exposed, and then you just call the self-test on your defined image. I did this yesterday night, and essentially in our minimal image, there are one or two packages that do expose kind of a build ID. So build ID is added by the compiler linker to the binary, and there are like two files that still have such a build ID. Next task, go find the make file, add the flags to remove them, and then we are done. Now this is just the minimal image. If we go to a full-blown image, we have more layers, we have more components. So there is work to do, because essentially go to the next bigger image, rinse, repeat, rinse, repeat. Another example is the archiver. So there is a self-test for the archiver. So for example, if you use the archiver to fill your own mirror, this is the way how to test that the archiver does what it should and works reliably. So this could be part of your process and run before you actually update your mirror. Now, this is OE-Selftest is an infrastructure that can be used also for our own purposes. So we can write our own self-test. The folder structure, as I said, in your own layer, you just add the folder structure lib OE-QA self-test cases, and then your own test that you want to add. These tests, there are two things to note. The name here doesn't matter. We need to import OE-Selftest case, and essentially our own test will inherit the OE-Selftest case. That's number one. Number two, and that one was not easy to find, your test needs to be called test underscore and then whatever. So this test underscore is crucial or it will not show up. Yeah, so that was a tricky one. And then you can basically do whatever you want to do in here to verify what you have to check. A common problem is that you need to add variables to the build. And that's the quick intro here. So you can define new variables in this way. And there is a call, add config, which will add this variable to the environment, yeah, to the bitbake environment. You can also remove the variables then later on again. Calling bitbake is then done with this bitbake and then the bracket for the options call. So you can execute complex builds then in here, and then afterwards you can evaluate the outcome. And that's how those self-tests are essentially constructed. And in this hello world-like example, I do test if, well, this customer variable ended up in the environment. How to call it? Well, same as before. We call OE-Selftest, and now we can execute our own addition. Okay. Any questions? Okay. Thank you.